truncated surface.
Something that happened in the 20th century, particularly with the advent of quantum mechanics, was an idea became very widespread among physicists that that the kind of confidence we had formerly placed in these techniques was reaching its limits.
It's always going to be a beginning. Math, we're going to come up with different things. It's always going to evolve. God is going to give us more. He's going to let us have that more information that we're going to wind up evolving.
It's uncomfortable to be uncertain or feel stupid or not know what you're doing or wonder what's going on in a situation. And a lot of people, are forced through that discomfort when they're getting their education. But then, they like, there's a certain security in being good at what you do and mastering a small domain, and then not being forced into a different domain where you feel really out of sorts and dumb.
Very much of the thrust of my own work over the past 20 years has been directed at, and I know that this is something that I didn't manage to, this is a view that I didn't manage to convince you of in the course of the quantum mechanics course. But all I can say is what looks right to me. And what looks right to me now is that these conclusions about the collapse of mechanism in the face of quantum mechanics turned out to be premature. Okay? It turns out that if you work a little harder than those guys did, and you insist on thinking a little more clearly than those guys did, reasonably mechanistic sorts of pictures of what's going on, even in the case of quantum mechanics, become available as well.
Thinking about this kind of question, it is actually natural to think about time as being an extra dimension. And this is all about, Einstein really convincingly showed that time and space are kind of intricately linked up with each other, and that you can rotate one into the other in a kind of funny way. So really there are 4 directions that we know about. And, well, there are some theories that there might well be extra dimensions that are kind of curled up too small for us to know about.
One shouldn't say that too glibly. There are surprises there. There is this phenomenon of non-locality in quantum mechanics, of things being able to affect one another without touching one another, and moreover, without touching anything that touches one another, and without touching anything that touches anything that touches the other, and blah, 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 blah. This is a real shock to our toaster-trained intuitions about what mechanical objects behave like. But nonetheless, it looks like we can explicitly write down a set of laws, we can explicitly develop a clear physical picture of what's going on with these systems in the way that people involved with quantum mechanics throughout most of the 20th century thought that we couldn't.
People have been thinking for so long that eventually they would have gotten to this point. I'm sure 100 years from now, somebody will have an even more abstract theory about something completely different. There's nothing to do with that, like vegetables or something.
I mean, I think there's a certain humility in paying attention to history. Because, I mean, when you realize that everyone before us didn't really have a complete clue what was going on, but they thought they did, then, well, gee, I mean, it'd be pretty arrogant not to draw the conclusion that we also don't really have a clue what's going on, we just think we do.
The issue of quantum mechanics was a particularly interesting issue because this was the first occasion. There had been for many years critiques of this mechanistic picture of the world, as it were, from the outside of physics, okay? That there were all sorts of mental phenomena, all sorts of ideas about free will, all sorts of ideas about meaning, so on and so forth, that people insisted again and again no mechanistic account of the world could do justice to. What was unique about quantum mechanics is that it looked like the mechanistic project was failing from the inside, not from the outside. That is, it looked here like the mechanistic project was going to fail not just for ideas or for consciousness or for meaning, but for rocks, okay? Even rocks, it turned out, weren't going to be thoroughly mechanistic objects.
Where are you going to go without numbers, without calculations, without formulae, without equations? I don't know.
If somebody says to me, and I have the impression that this is part of what you're interested in, if somebody says to me, why do you think this way vis-a-vis, say, economic policy in the third world?
Which is what econometrics is about. We observe, we collect data, and then we process it using statistical methods.
Here's an important decision that we want to make. How should we go about doing it? About policy, about economics?
What has been the result of a policy intervention? So if Congress votes a plan to solve the mortgage crisis, how can we evaluate later, based on data that we collect, how successful this plan has been?
There is this kind of tug. Look, there are these techniques that work well for fixing toasters.
Mathematical reasoning encompassed in a relatively simple mathematical structure to throw light on important and complicated historical processes.
There are these techniques which, in the cases where we can clearly and vividly and quickly see the result of this kind of reasoning as opposed to the result of that kind of reasoning, there are certain techniques of thought that prove successful.
Two philosophers get in an argument, and they could argue for the rest of time and never agree. I mean, two mathematicians get in an argument, and they might argue for a really long time, but one of them's incorrect. And in every math argument I've ever been in or witnessed, someone realizes that they're wrong and says, "Oh, you're right."
Here's what's impressive about the toaster case. What's impressive about the toaster case is no matter what their initial prejudices, everybody eventually agrees on the right way to build a toaster.
I mean, the way we do math, it's all based on it's all about writing down a set of rules and following those rules.
We have to try and make things logical because that's the only way we know how to make them coherent.
We know that you can't establish essential truths. The most one can do in scientific reasoning, even in much more developed sciences like physics, is to make predictions that are consistent with the observed phenomena. And to that extent, I think in a more humble sort of way, economics can also rely on this sort of test.
I think of master categories as enormously powerful, and they're partly powerful because they do explain. And this is also the notion of an established proof. It explains.
This method enables one to concentrate on the relationships between the essential variables. So rather than, if you just make a historical account, you know what happened, but you don't know, what were the necessary connections between the different events, right?
But precisely because they are so powerful and so clarifying, I also argue that they blind us.
Maybe. I mean, I guess the reason why it's possible to reach a consensus is because, the discipline is restricted to things that can be proven via these means, and if something's outside the domain of those proof capabilities, it doesn't count as mathematics. And I mean, so in that way, we are restricting it for the sake of this decidability. But I mean, it so happens that didn't, it left us with plenty of richness.